This conference will now be recorded.
Does it work now?
Not yet, only the phones got the presenting privileges, not the PC.
I
Oh,
couldn't.
yep, got it,
Okay.
got it. I think it's a small delay.
Okay, good morning. Today we're gonna have Marian from Marinox to present fine-grained and ordered ECMP. Marian, if you could please share and present. Thanks.
Mm-hmm. Yeah, thank you, Rita. There is an ongoing ECMP work group for SAI, where we are trying to come up with the enhancements to ECMP that can solve more specific use cases. So one of the enhancements that we worked on were new types for the ECMP that I want to walk through with you and explain why we want them to be inside and how to use them. So first, today we are going to discuss the new ECMP types. So if for those who remember how ECMP looks like in the APA today, so it is exposed as a type called SAI next hop group type ECMP. So this one solves the general use cases where you want to do the distribution, let's say from the Tor switch to multiple T1 switches. You don't have any specific criteria. You just set some hashing, default hashing on the switch, and then the traffic is redistributed distributed to all the T1 next hops. So usually in this case, the switch doesn't care how the traffic is distributed and how the next hops are ordered, what is the size of the group, and also the only way to control the distribution or the amount of distribution of traffic to every next hop is by assigning a weight to that next hop member. So this solves the general use case, but also we came across some not that general use cases. For that, I want to introduce two new types. So first, the current SAI next group type ECMP, well, it's still there, as you can see, but now for more verbosity, it is aliased to the name next group type dynamic unordered ECMP, because the size of the group is dynamic, and the application does not have a control over the order of members in the group, which is sometimes needed for the other use cases. So one kind of the next level of applications control over the ECMP group is to allow the application assign an order to the members. So assuming the case that we have multiple T1s in a data center that each of them is connected to a set of Tor switches, and the goal here is regardless on which T1 switch the packet lands, it should be distributed to the same T0 to the same Tor. So for that case, what the application would like to do on each of the T1 switches is to sort the next hops in some predefined manner, and then assign this order to to members in this group. So another use case is when you not only want to control the order, but another requirement that comes in is a fine-grained control over the distribution of the traffic. So as I said today, the way that application can control distribution is by assigning the weights, but this could be implemented by giving an application a full control over ECMP. So this basically means that the hardware will expose via the SAI driver the full, usually some large size ECMP table in the order of magnitude of hundreds or thousands of entries in this table. And the table is fixed size. The entries are assigned by the index, and basically by controlling how many entries each next hop occupies, the weight is controlled. And also for it is very this is one way to work with it. Another way to look at it is in the case of failover, when one of the next hops becomes like with the document that I have attached to this pull request, this example, first of all, we would like to see the same ordering from two TORs. And the second one is in the case when one of the next hops fails, we would like to see that traffic that previously was landing on the healthy next hops is still going to the same next hops, but the traffic that was hashed to the failed next hops should be redistributed to all the healthy next hops in the equal manner. So we cannot express this behavior with the current SAI API. So for that, I introduced a new type that carries additional attributes that allow for fine-grained control of entries in the following manner. So the hardware, as I said, exposes a large fixed table. Each entry occupies each next hop occupies multiple entries in this table. And when something bad happens, like one of the next hops becomes unreachable, the application is responsible for looking at that table and reassigning the pointers to this next hop to the rest of the next hops. So this is a way to control the weights and the traffic distribution. So going to the pull request. So as I have shown, we've got two new types: dynamic unordered ECMP. This is the alias for the old name. Also, there is dynamic ordered ECMP, which is kind of like the old one, but you can specify the order, and the fine-grained ECMP, where the application has the full control over the table. So the changes that were done to the next hop group type itself is two new attributes, which are only valid for valid only for fine-grained ECMP. So first one is configured size, which specifies the requested by the application size. And the second one comes together with it is the real size. This is a read-only attribute, also should be used only with fine-grained ECMP. This one specifies the actual size that was allocated by the SAI driver, because usually for the simplicity of managing the resources, those sizes cannot be like arbitrary size, but they are usually aligned to some values like the power of 2, something like that. And what application requested is not necessarily the same size that the hardware allocated. So to know what the hardware actually allocated, the real size value should be used to know how big the table really is. So this real size should be greater or equal from the to the configured size. So another way to get the real size is I'm working on a small enhancement to actually being able to query the available ECMP sizes beforehand and then do the judgment and configure to the right size, but this will come in a separate pull request. So for now, this is the one method. Another one will be introduced a little bit later, but this is basically for the capability query enhancements. It's not really the functionality of the ECMP. So this is all the changes that were done to the next hop group object. Next one is next hop group member. So first thing that needs to be changed is, as I have shown in this picture. So in case we want to kind of have a fine control over the traffic redistribution in case something in our group changes. So the way to do it is to do reassignments of our members. So let's say member with index 1 usually was assigned to next hop 112, sorry, but now it needs to be reassigned to 1111. So the mechanism to do that is not to remove the old member and to add a new member, but for the sake of simplicity, we keep the same member that carries the same index, but we just set its attribute next hop ID. We dynamically set the next hop ID from one to another. And in this document, there is actually an example. You can look at it afterwards if you want to, how to operate with the fine-grained ECMP and how to do all the settings. So moving on, the two new attributes to the next subgroup member. So they are specific to the type. So first one is next subgroup member attribute index. So it should be used only with the fine-grained ECMP group. The valid indices are from 0 to the real size -1, of course, and it basically assigns your member a specific index in this large table. So index 0, 1, 2, and so on, and to real size -1. So this is a strict index, like an array, because the application has a full control over the ECMP, so the application is responsible for filling the full table. Second attribute. So second attribute is should only be used with dynamic ordered ECMP. So this is this type kind of in between that allows you, that keeps the simplicity of the resource management from the current ECMP, but also allows you to specify the order. So this is not a strict index, so it's called priority, and it specifies kind of the ordering within the group without it being strict, because application is not aware of the size of ECMP group. It doesn't do any specific settings, but what it wants to tell the driver is that the members should come in that order. So before that, the membership was fully unordered, and now it can specify the same order in 2 or more switches, so that if the packet lands on any of those switches, it will be later on distributed via the same ECMP group to the same next hop, regardless of which switch is going through. So that's it. some small change to the spelling, but it's not really related. Yep.
Hey, so on the weight and the priority, like couldn't we use the weight, or what is the behavior now with if both are specified?
Oh, weight is not supposed to be used with the fine-grained DCMP, because fine-grained DCMP defines precisely the index in the table, so there is no such thing as a weight. Weight in fine-grained DCMP is done by the application.
No, my question was about the priority and the weight.
Oh, priority in the weight. So they are orthogonal. Weight tells how much traffic basically you want to distribute to this next hop, and the priority tells you the order of the member in the next hop group.
Okay, so both can be specified.
Yeah, yeah.
Hey Marian, I have a question like for this priority one, let's say, so finally in the SAI adapter, if one vendor put in one order, another vendor put in another order, then do we have to specify like some mechanism in the SAI to make sure each vendor give the same order for this priority attribute?
I don't think that this should be supported across vendors, because the hash itself is not the same across vendors.
No, because if there are two different TORs, one TOR is some different vendor, another TOR is different SAI vendor.
And you want the priority to work, like you want to order the ECMP group across different ASICs?
Yes.
Well,
like do we specify the increasing or decreasing, or like otherwise, yeah.
you can, assuming that two different SAI implementations for two different ASICs ordered the group members in the same way, it's still not guaranteed that the hash result will be the same. So I don't see how this is going to how this matters if you don't have the same hash result. So this is supposed to work only with the same ASIC. If you want to stack multiple switches with the same next hop group, you need to basically have the same ASIC having the same seed and hash configuration, because this is another thing. ECMP only uses the hash result.
Yeah, I think that point is fair enough. Yeah.
There was one. Sure, go ahead.
Yeah, sorry. So the question is, this is implemented on the Sonic side to control fine-grained control of this next hop ordering?
Yes. So ordering is specified by the next hop. Ordering is specified by the application, by Sonic. Yes.
Yeah, I was just wondering if this can be an attribute where you tell each vendor to perform this in a fine-grained fashion, like as you specified, but so that you don't have to keep this kind of a exact ordering associated with your next hop, the ECMP next hop. I wonder if that
so
would be.
This is kind of the point of exposing it to application, because when you leave it up to the SAI driver, so that SAI driver will make all the decisions, like how to order them, how to reassign them. But when it's fully in control of the application, then the order and all the reassignments will stay the same, even across multiple switches.
Right. But it's a scheme,
so
right? Like you given the example how the index is being replaced in that order, but can we give that same scheme and expect the implementer on the SAI side, lower end, to follow that? Then we don't have to keep all this it's kind of like hardware specific, very hardware specific on the Sonic side. It's more common.
Yeah, so it is kind of more advanced than the regular ECMP, I agree, but it is more in the same time it is more transparent, and it won't make the SAI driver kind of doing some bugs or something like that. If the application does the work once, then it is expected to be the same. So I think that here exposing it to the application is the best way, because defining the schema could be a tricky one.
Okay.
Like saying how you want to, you need to kind of give the SAI driver the function by which it would need to order the members, some criteria for that. And also, like in the picture that I've shown, if one of the next fails, you also need to kind of describe to the SAI driver how you want it to reassign those hash buckets to the different next hops. And how to do that, I think it's going to be more tricky than just exposing the fixed size table and telling application, okay, now you have the full control and you know what to do.
Yeah, I mean, you could indicate, say, hey, when I'm removing one, just do a equal redistribution, and the meaning of that is wherever, like you had, wherever this 1.1.1.2 was occupying, just have an equal redistribution where you use 1111, and then the next one's 1113, whatever is still in the table, right? Then it achieve what you want to do, but yet the application don't have to know all the details and keep track of exactly which which next hop is in this ECMP. I mean, there's kind of like pros and cons. Okay, so you can have the application know a lot, but then now you're pretty much tied down to a specific vendor now. That's what I'm worried.
Well, you're on one side, yes, but these use cases are usually kind of developed for more than one switch, and if you want to ensure, as I said, the same hashing behavior on more than one switch, then you anyway are tied down to the specific ASIC, unless you want to replicate the kind of the full set of TORs or T1s with a different vendor, then then the whole sets will be different vendors. But within the same set, yeah, you for these use cases, it should be the same vendor because of the hash behavior. It's not that the simpy behavior, but I would say this is more because of hash. But yeah, so this could be another way, but I see it more complex in terms of SAI definition. So this was why we chose to expose everything to Sonic.
Okay, thank you.
Hey, I'm not exactly sure the index and priorities. So each next hub has an index as well as a priority. Is that correct?
Oh, yeah, right. So not really. So the index is only used with a fine-grained ECMP type, because you see the fine-grained ECMP has a fixed size table, and each bucket in the table is accessed by the index. So this is a strict indexing like in the array. But there is a different type, which I said something in between, which is the dynamic ordered ECMP. So this is a different type, meaning this will be a different group for which the priority is supposed to be used.
Oh, okay. So how's the priority used in a dynamic ordered?
So this is a less strict indexing. So it shouldn't be it's not required to be sequential. Like you can have holes in there, but then the SAI driver will map this to the corresponding indexing inside by keeping the same order as like in this in the priorities. So for example, if you have 3 next hops priorities 1 to 4, what the SAI will do, it will map them to indices like 1 to 3, keeping the order.
I see. Okay.
Yeah, and otherwise it's just as the same ECMP that was used before.
Why do we
Nothing
need
else.
that if we already have the index? So that's this
Yeah,
is another option.
Yeah, so this is we discussed it with Gowan, so we decided that we should also have this something in between when the application does not want to have the full control over the ECMP table, or it doesn't really need this large ECMP table, but it needs a small ECMP group. But when you have multiple T1 TORs and you want to ensure that the packet is hashed every time to the same TOR, no matter which T1 it's going through, then all that's needed to be done by the application is to specify those priorities. Just sort the next hops, specify the corresponding priorities, and
is priority the best name for this? I mean, it's
well, this is what I usually call this loose indexing, when you don't have it strict, but it specifies the order, when you can have it non-sequential.
right. Well, I mean, it's the naming here. So priority, it seems to be like, let's say one next hub has a higher priority than the other next hub, then that higher priority next hub might potentially get more traffic. That's kind of the intuitive meaning, but this is not the case here, right? It's just basically the ordering here, like the sequence here, like how it's programmed into the ECMP table.
Yeah, so
it's a little, Bharan, it's a little confusing because see, you're saying index and priority cannot be used together, right?
So index is for fine-grained ECMP, priority is for dynamic ordered ECMP. Yes, so this is a loose order.
Right. So you're saying that if I have the dynamic ordered ECMP, then this is specifying loose indexing, right? That's what a description says, index specifying members order. So couldn't I simply use the same member attribute index for this purpose when it's dynamic ordered ECMP? Why do you need 2 attributes?
It could, so it's just the API definition. So it doesn't really. Yes, so we can think about if you suggest joining them and having like comments with a different description per ECMP type. It's also an option. So
I think one way it's cleaner actually if we keep separate, because the index is really fixed position.
The conditioning is being provided in the comments, right? Rather being logical. So it's not really helping. You're having one attribute sitting idle, serving the same purpose.
Yeah, I see your point. Yes. So it could be the case. Yeah. So I will circle back on that.
Yeah, but the index has some mean and max associated. Priority is just loose order. So the index is bound with the ECMP size, the grain ECMP size. If you see the comment on the index, there is a mean and max.
Yeah, but this is not like the annotation specifying something that will go to the metadata. Currently, SAI does not have this kind of annotation, as far as I know. So this is just a comment for the programmer's reference. So this could be the possibility. I would probably also ask Goan what he thinks about it.
So I think the there's a one tricky part is that for the loose ECMP, if we use index, there could be holes, right? So if we name it as an index, we discussed that there could be some holes there, and so that's why we choose to use the name priority, because the thing about initially you have, let's say, 3 ECMP, 3 next hops, and you name that as 1, 2, 3, and now you remove the second next hop, where the index is 2. But in that case, you have you have 2 next hops and one index with 1, one index with 3. But in this case, what the SAI will actually do is to resize the next hop group to be 2, right? So in that case, one of them next hop is 1 and another next hop is 3. It's a little bit confusing to use index in that situation.
I don't know. Okay, because the description pretty much starts exactly the same, so that's why it's misleading. There also it says index specifying something. Here also it says index specifying something. I don't understand why couldn't the same thing be used for both purposes. I mean, you're just getting a value. That's all. How you use it is different. Maybe the description can be changed a little bit.
Yeah, I think in the strict, sorry, the if we supply the group size, then index makes sense because you expect to fill all the sports, right? So but if it's dynamic ECMP, then yeah.
It's still okay, right? Because every entry has an index. It doesn't necessarily, I mean that it's an index to its data structure, right? It's just an ID to, maybe we can say ID instead of index for the row 269. So in the strict, the ID needs to be in order. In the loose, the ID could be in order decided by the SAI driver or the ASIC.
Yeah, maybe that's more generic. That makes sense.
And we could probably have an attribute called loose or strict, if that will be more clear.
So that's specified by the type anyways.
Oh yeah. I forget what's the type name now. Yeah. If it's not strict, then it means loose. Yeah. Or fine. If it's not fine grained, that means loose. Something like that.
So sorry, what is the suggestion to change the priority to combine the 2 attributes and then both use index? Or?
No, ID.
Oh, change the priority to ID?
No, index become. So is the concern that in the priority case, meaning the loose case, index, it's not really an index. That's the main. Is that the main reason why we introduce a different name called priority?
Yeah, I think so, because in that case, when you change the group size, the index doesn't really mean the the exact sport you occupy in the in that ECMP group, right? So because yeah.
I see. So that's why I suggest instead of call index, just say ID, right? So next hub has an ID. So in the fine grain case, it's strictly in order, like 0 to max -1 ID in this order. In the loose case, it could be 1-3 or 3-1 in the other example. Depending on, oh no, 1-3, right? Should be 1-3 in the loose case. Yeah, then it's still an order, but not. It's not really an index in that case.
Yeah. So then I guess we'll put all this into the explanation, right? In what you have said, right? So whether it's a loose or strict case, we both use ID, but the ID in the fine grain case, it will mean exact index, but for the dynamics case, it will actually mean the priority, right? So
could be, but my I was thinking for priority, it's not really priority for the next hub, because let's say priority in the ACL context, right? Priority is like so long that this a higher priority entry is hit, then the lower entry is not going to take effect. It's kind of like a wait, right? But it's not the case here.
I get that. But for example, if we just changing the group member attribute to group member attribute the sequence, would that be more more accurate?
You mean this priority change to sequence? Or
yeah.
No, the new combined attribute that we are talking about, that should be called ID or sequence.
You mean row 269 here? Or which one?
I think that there were two proposals, right? So why is just changing the line 283, change the priority to sequence?
Oh, okay.
That's one proposal. Another proposal is to combine these two attributes and give a new name, and then they may be ID or sequence.
ID would be more suit, yeah, for the second proposal, yeah, because it's associated with specific next hub, right? Sequence is more characteristics for the whole sequence, yeah, they are similar, yeah, a little bit similar sequence and in ID, yeah. So you're saying 283 could be changed to sequence? Is that what you're saying?
That's one proposal, right? So because the I priority is a little bit not that accurate. Usually, if it's a priority, meaning that it's override other next hop, right? So that could be a little bit confusing. And if we change to sequence, it just means sequence, right? So the first three, the third, the second, as a sequence, I don't know if we allow the whole in sequence or it's okay. Because I think the problem is that when you the problem we want to avoid is that if we change removing or add member in the dynamic next hop group, then we don't want to change the attribute other members, right? So if we remove the second member, we don't want to change the third member to say, okay, now you have to change your index to be 2. That will be a little bit difficult for the application to write.
Right, that's why I feel ID is quite straightforward. It's just an ID for that next hub. Yeah.
Mariam, there's one more question on the next hop ID itself. You're changing the flag, right? So what is that? Why is that requirement?
For the fine-grained ECMP, the idea is to remap the next hops in the table without removing and creating the object themselves. So you're just using the existing member, but setting the attribute of that member. Like, okay, let's go to the example. So if you want to remap the next hop 1112, so you iterate over the group and just set the next hop ID attribute to a different value, and then set this attribute without removing and adding members.
But I mean, like, is there a problem in removing and adding?
Well, first, I wouldn't expect the next hop group of type fine-grained ECMP to be used in a route before assigning the full table of members. And then I wouldn't expect the members of the fixed size table to be removed when it's already used. So you can remap them, but you cannot leave a hole again there.
Okay.
You can change the pointer, but yeah.
This looks like a divergence from like the entire spec where, you know, any such member object is there, the two parent objects are never like modifiable. So I'm just seeing this as a new exception now.
The parent objects are not modifiable, or maybe I misunderstand you. I just
Meaning
from
it's always a create only. It's never a create and set for any of the member objects. Maybe that was a coincidence, but then we are kind of changing the design now. Now any member, basically their parent, you know, one of the two components could be changed as well, not just create only.
So the members you mean are create only, right?
Well, yes, I'm saying yes. In a member, like you can take ACL or IPMC or ECMP or any of these. So whenever we create such a group member, it's always create only. The two parents are always create only attributes. The two parent objects.
Okay, I see. But I don't have with this kind of behavior where you would have to only remove the member and then add the new member.
Yes.
What should the ECMP table look like in the point of time where you call SAI API remove member, but you haven't yet created anything there? So there is a hole.
Mm-hmm.
So I understand the concern, but on the other hand, there is kind of an undefined behavior there, which
Okay.
I want to avoid.
Hey, coming back to the previous index and priority, thinking more about it, I think keeping two separate attribute would be cleaner. Basically, 269, it's because it's for specific next hub, and actually for the same logical next hub, for the fine-grained case, you will have multiple next hubs. Meaning, for example, 1111, right? This next hub 1111, you could have multiple copies of 1111. Is that correct? From the application. So each one should assign a different index. So I think using ID could be confusing. Right, Gohan? Yeah. So
yeah.
yeah.
One of them.
Because now if we assign the same different copies of this next hub with the same ID in a fine-grained case would be confusing. Yeah, I think different index for different copy would be better. Yeah.
Yeah, I think the priority is maybe we should change to another
Sequence, right? Yeah.
term. Yes.
Yeah.
Because it's yeah. Well, what do you think of Maria? So the priority?
Yeah, probably the sequence ID, sequence number, maybe something like that.
Yeah, sequence number. Yeah. And then maybe 269, just make it very explicit. It's for fine grain.
Oh yeah, it is in the comment.
In the variable name, the attribute name.
Okay. Yeah, probably that's also a good idea. Put it as a part of the attribute name.
Yeah. Is it really true that it's only meaningful in the fine grain case? Meaning, if it's non-fine grain, can it be used or no?
Well, others do not. For other types, the SAI drivers manages the size of the group and the indexing. So only this type allows the application to manage such thing.
Okay.
Okay, so that's it. Pull request is up for review. There is also a document explaining all of that together with the pull request.
Okay, yeah. Thanks. Anyone has any other feedback? We still have time.
Yeah, so if I can, I have a small PR to discuss.
Hi, Camille. Yes, I think I'm finished. So.
Okay, sure. Yeah. Thank you. Yeah.
So can someone make me a presenter?
Yeah. 1 second. Camille, you could present?
Yeah. Can you see my screen?
Yep.
Yeah, so I would like to discuss changing the debug counter from debug counter index from read-only value to a mandatory on create and create only in a key. So currently this value is assigned by vendor when the debug counter is created, and we can read that value using that read-only attribute which at this time. And my proposal is to change it to a create by user, to assign the index by user, because we in the Sonic we don't consider read-only attributes to be used in the process of comparing objects when we switch from one view to another one. And at that, if that object is read-only, is not participating, and we cannot tell which debug counter match to which debug counter. And yeah, and that's it. So are there any questions?
But does the application need to change as well?
Sorry, what was that?
Does the application need to change how to use it?
Which application? You mean like Orc Agent?
Yeah.
Yes. Then this, because right now this attribute is not mandatory, so the application would need to change to actually supply this index.
Okay.
Yeah. So in this context, this is a breaking change.
Okay.
So these kind of changes, Guhan, like where would you integrate them back into the spec, like in a future version like 1.6, or what would you do?
I didn't get the question.
No, like would this go into, would this become part of 1.5 or no?
Oh, yeah, is Danny here? I would like to Camille, have you discussed with Stanley? He need to change his application. Is that correct?
No, I didn't discuss that.
Okay. Maybe it's discuss, because is he aware of this change? I don't know.
No, probably not.
Okay. Oh, okay. Then let's this, because it's changing application, right? So then he's I don't know what implication do we have on his application? Yeah.
Yeah, no, that's fine. We can resolve that offline over the weekend and bring that on the next meeting.
And what is the reason? Is this related to the warm boot case?
I mean, this is related to reason that on the comparison logic, yeah. So to make sure that this index value will participate in the comparison.
I see. Okay. So instead of return by the SAI, the application now need to decide what index to use?
Yeah.
Okay. I see. Yeah, let's have a think with yeah.
Okay, so I think we are out of time.
Okay. Anything else from anyone here? Okay, thank you everyone for joining today. Thank you. Bye.
Thank you.
Bye.
You guys, bye.